On to 2.5 part 2. We're still talking about algebraic proofs. This time, though, it gets into more geometry and more expressions rather than just solving equations. So, just like algebra, geometry can also use numbers, variables, and operations. For example, segment lengths and angle measures are numbers, right? Lengths and measures are numbers. So we can use these same properties of equality to write algebraic proofs in geometry. Those properties of equality that we talked about were addition, subtraction, multiplication, and division properties of equality. We also had the reflexive property, symmetric property, and transitive property, along with distributive. And we also had simplifying steps where we would just combine like terms. And then we also had substitution where we can plug stuff in. Okay, so that's what we talked about last time in part 1. And now we're going to solve some stuff about geometry. So here's a helpful hint, and I think I've explained this before. AB represents a length. And remember, a length is a number. AB, though, with a hat on it, is a segment. It's a figure. So we're talking about the figure segment AB. When I just have AB with no hat, I'm talking about its length. How long is it? What number is it? Okay, so AB is just like a variable representing a number. And that's going to be helpful to us because X is a variable representing a number, right? Well, AB is almost the same thing as using an X. Okay, so our first proof involving geometry, and it wants us to write a justification for each step. So what do we have here? Well, it gave us the equation NO equals, here's NO, equals NM plus MO. So we need to write a justification. Why is that true? Why does the whole thing equal a piece plus a piece? Oh, wait, whole equals piece plus piece. That sounds familiar. Miss Eck was talking about that in chapter 1, I remember. And in chapter 1, this was a segment, right? NO is a segment. And we're adding the two pieces. Hint, hint, nudge, nudge. That'd be segment addition. Segment addition says the whole thing is equal to this piece and this piece combined. Segment addition here. Okay, well, if you remember the hint in the step before, AB represents a number, right? So I have NO, NM, and MO. They don't have hats on them, so they're representing a length. So let's fill in here those lengths. What is NO? NO, NO, NO. Here it is. N2O is represented by the length 4x minus 4. Okay, so I put that in place of NO, then I just put my equal sign. NM, N to M is represented by the piece 2x. And MO is represented by 3x minus 9. So what step is that? I have to justify it. What did I just do? Why can I put 4x minus 4 in place of NO? Oh, in place of. That's substitution. I'm substituting those values in for the variable. Okay, so now that I have an equation, something to work with, remember I'm trying to solve this equation, what do I do first in order to solve? Well, I want to combine like terms if I can. I notice I have a 2x and a 3x, so I'm going to combine that to be 5x, and then it's minus 9, and then it's 4x minus 4 on the left side. What is that step called when I combine like terms? Or simplify. I didn't do anything on both sides of the equation. If I don't do anything on both sides, it's called simplify. I simplified my x's to be 5x. Okay. Notice how there's only 2 lines given. That's fine. You may need more lines. Just draw them in on your homework if you need more lines. But I'm going to actually sort of kind of skip a step, but I'll show you what I'm talking about. So if I'm going to solve this for x, I need to combine x's to one side. And I notice that I want to move this 4x over here in because I don't want a negative x. So this is a positive 4x. So if I subtracted 4x on both sides, first of all, what's that step called if I'm subtracting on both sides of the equal sign? If it's on both sides, it's a property of equality. And which property is it? Oh, I use subtraction, so we're going to write subtraction, property of equality. Okay. Notice how I didn't write minus 4x on that whole line because I'm trying to save space because it only gave me 2 lines here. So when I subtract 4x, I'm left with the minus 4. 5x take away 4x is 1x, and I'm left with the minus 9 over here. So what step did they just do right there? Well, when I cancel out and take a 5x and a 4x and I combine those terms, I'm simplifying. Notice how I don't have a line for it. Okay, so sometimes you don't have to write the simplify step. Simplify steps will always come after a property of equality. Okay, whether you're subtracting on both sides, or you're adding on both sides, or multiplying or dividing, anytime it's a property of equality, you're going to have a simplify step. That being said, because it's always kind of there, we don't write it all of the time because we know after we subtract 4x, we're automatically going to simplify it. Okay, so that's what I mean by I'm skipping a step here. I'm skipping the simplify step. If you want to, go ahead, add in a line and write simplify if you'd like. Okay, so now I have negative 4 equals x minus 9. What would I do to solve this? I would actually add the 9 over because x is on the right, so I need to move numbers over here on the left. And I'm adding 9. What is that called? When I add the same number on both sides of the equal sign, that would be addition, property of equality. And after I add, I'm going to simplify this to x equals positive 5. So I found out what x was using chapter 1 skills. This is something you guys did. You set the whole piece equal to, or the whole thing equal to piece plus piece, and you solve for x. I know you can do the left side. So what we're really working on is the justification steps over here on the right. All right, here's one involving angles. So again, it's a chapter 1 concept. And look, they're even nice enough they did the whole thing for you. Okay, so you need to justify. Why can you write what you wrote on the left and write out the property, the theorem, the postulate, or simplify over here in the justification line? Give it your best shot. I don't expect you to get it perfect right. If you do, great. If not, that's fine. We're learning from our mistakes in here. This chapter is tough, and you're not the only one who has ever struggled with proofs. Believe me. Give it your best go, and we'll talk about it after you answer the question. Okay, as you'll notice, the first line says measure of angle ABC equals ABD plus DBC. So ABC, the whole angle here, equals ABD, this piece, plus DBC, this other piece. So what property says the whole equals piece plus piece? And we're not working with a segment here. What figure are these? These are angles. So this would be angle addition postulate says the whole angle is equal to the two little pieces inside of it. Angle addition postulate. Okay, so that's line 1. What are they doing in line 2? How did they go from ABC to now 8x? What property or postulate says that ABD, if it's labeled 3x plus 5, I can put it in its place? That would be plugging in or substitution. And you could put substitution, property of equality, or you can just leave it as substitution. Okay, and look what they did in the next step. How did they get, well, 8x is still the same, but how did they get 9x minus 11? What did they do over here on the right side? Well, it looks like they combined the 6 and the 3 to get 9, and the 5 and the negative 16 to get negative 11. So what's that called when we combine like terms just on one side of the equal sign? We call that a simplify step. Okay, and the next one. It's hard to see what they did here. Somehow, this 8x is now a negative 1x. Negative 11 is still there, but 9x is gone. So what did they do? Well, what would you do if you had this equation and you were solving for x? What would you do? Well, I would subtract 9. Oh my gosh. If I subtract 9 from 8, I would get negative 1. And these would cancel, and I'd be left with negative 11. So, hey, that works. Subtracting 9x on both sides would get me the next step. So what do I call this step when I subtract 9x on both sides of the equal sign? That's the subtraction property of equality. Okay, and the last step, how are they going from this line down to this line? What did they do? Well, notice what changed from the second to last line to the last line. There's no more negative. So what did they do on both sides? Well, either they divided by negative 1 on both sides, or they could have multiplied by negative 1 on both sides. Because isn't multiplying by negative 1 going to get rid of these negatives and leave me with positive x equals 11? Yes, it will. So I am going to call this the multiplication property of equality. I multiplied by the same number, negative 1, on both sides of the equal sign. You could also, I'll put in parentheses, division would work, division property of equality, if you divided by negative 1 on both sides. So either one of those would work. Notice how when I subtracted 9x on both sides, they did the subtraction property of equality and the simplify step all in one. They kind of skip that simplify step. When you subtract 9x, it would simplify to negative x, but they don't write it simplified because it's kind of already given in our brain. So now, in chapter 1, we talked about how segments that have equal lengths are congruent. Okay, so when their measures are the same, they're congruent on angles. Okay, so equal lengths are congruent and equal measures are congruent. That means that those reflexive, symmetric, and transitive properties of equality, we can also say those are properties of congruence if we're talking about figures. Okay, so numbers are equal, figures are congruent. Keep that in mind. So what does this property look like? Segment EF is congruent to segment EF. Which property of equality does that resemble? Well, it kind of resembles the reflexive property of equality, but this time we're using a congruent symbol. And we're talking about segments, not lengths, so they have hats. This is the reflexive property of congruence. Let's look at the next one. If angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. What does this sort of resemble? It resembles the symmetric property of equality, but this time we're using a congruent sign again, and we're talking about the angles themselves and not their measures. And the last one you could probably guess, but if segment PQ is congruent to segment RS, so for instance, here's PQ, and it's congruent to segment RS, then and RS is congruent to segment TU, well then we can just say that these two are congruent, right? If PQ is equal to RS and RS is equal to TQ, then that means these two are obviously equal. This is the transitive property of congruence. Before it was property of equality, now it's congruence. Again, numbers are equal, figures are congruent. So if you're talking about lengths or angle measures, then we use equal sign. If we're talking about segments or angles, we're using congruence. So identify the property that justifies each statement. Angle QRS is congruent to angle QRS. Well, immediately when I see that congruent symbol, I know it has to be one of these three properties of congruent. So I'm just going to go ahead and write prop of, and I'll just do the congruent symbol instead of writing congruent. But which property? Well, what do I notice on both sides of the equal sign? Oh, QRS is seeing its reflection in the mirror. So this is the reflexive property. I'm going to abbreviate. Next one, the measure. Oh, we're talking about measures, so it must be an equal sign. Okay, so some property of equality now. Angle 1 is equal to angle 2, so that means that angle 2 is equal to angle 1. It's not changing anything but the order. So when we change the order, that's the symmetric property, right? Because we can change the order of the m's and it's still the word symmetric. The last one, or sorry, part C. Part C says segment AB is congruent to segment CD, and CD is congruent to segment EF. So that must mean AB is congruent to EF. So please don't get caught up in all the letters, okay? You can even label this 1, AB is 1, CD is the second one, oh, CD again, oh, here's a new one, EF. So what property is it when I use 3 different objects? That's a transitive property. And is it equality or is it congruence? This one's congruence. So transitive property of congruence. We're eliminating the middleman. AB is congruent to CD. CD is congruent to EF. So just let's skip through CD and go straight from AB to EF. Okay. And part D, 32 degrees is equal to 32 degrees. So 32 is looking in the mirror. He sees his reflection. This is the reflexive property. And it's not congruence. This one is equality. Okay, so I've gone over 4. I would like you to go over these 4. This is to check it out and identify the property for these 4. Okay, so for the first one, you should have gotten the symmetric property of equality, switching the order of these two around the equal sign. The next one, you should have got the reflexive property of equality, 94 seeing as reflection. And the third one, O is equal to A and A is equal to X. That means 0 is equal to X. We're eliminating that middleman. We're eliminating A. It's using 3 different parts, 0, A, and X. This would be the transitive property of equality. Angle A is congruent to angle Y, so angle Y is congruent to angle A. We're switching the order, but it's around the congruent sign, so this is the symmetric property of congruence. If you have any questions, please ask Ms. Henderson. She is more than capable of helping you. Ask your neighbor, and you can find some online resources. But please just try your very best. It does no good to sit there and not ask questions if you're not understanding.